Hi everybody. I hope you're enjoying all your VE Day celebrations. I hope you've got some cake and you've got a nice cup of tea. Maybe you've made a cup of tea for your family. Hopefully you're having a picnic and celebrating later. I'm just going to enjoy this piece of cake. Oh, Mrs. Drew. She's done 5 days of maths, so she wants me to make sure I do the answers. But it's VE Day. I do hope that the children are not doing their maths today, but I'm going to do the answers. So children, I'm hoping that you aren't watching this today. I'm hoping you're watching it yesterday, Thursday, or you're looking at it next week, because you should be celebrating VE Day with your family, not doing your maths, but I'm sure you've done it at some point, so want to see the solutions. So this week's rapid reasoning, last day today, some festive Union Jack bunting as well to celebrate. These are the questions for today. So let's have a look at the first question. It looks quite straightforward. We've got some Dean's apparatus there, showing us 1,000, 100, a 10 and a 1. Complete the value for each diagram. Right, let's look at the first one. So I've got 3,000, 200, and then 8 tens, 80. That seems quite simple. Wants to know the value, 3,280. I can see what they've done now on the next one. So I've got 1,000, 300, I've got no tens, and 6 ones. So they're obviously checking here that we put the placeholder in to show that we have no tens. So I've got 1,306. There we go, that's question 1. Nice, easy start for us today. So for the next question, it wants us to circle the 2 prime numbers. Now we know that prime numbers are numbers that only have 2 factors, 1 and itself. So looking at that, I can see straight away an even number. So if it's an even number, it must be a multiple of 2, so therefore it's got 2 as a factor. So let's get rid of 48, because that's even. So I'm going to look at some other factors now. Let's have a look to see if I can see anything with 3 as a factor. Yep, on the left there, we've got 27, which is 3 times 9, so that can't be prime. I can see another number that has 3 as a factor. You might have recognised 39 as being 3 times 13, or you might know the test of divisibility for the 3s, where you add the digits together, and if the sum of the digits is a multiple of 3, that means that the number is a multiple of 3. It only works for 3s and 9s, but that's a good test of divisibility. And when I add the 3 and the 9, I have 12, which means that 39 is a multiple of 3 because 12 is. So I'm looking at my other 2 numbers. I can check they're not even. They are not multiples of 3. I do not need to test the 4s. I don't need to check whether 4 is a factor because they're not even, so I don't need to check 6. The test of divisibility for the 5 times table is, does it end in 0 or 5? No, neither of them do. The only other number I need to check is 7, and 37 is not a multiple of 7 because 35 is. So I'm going to say that one's prime. And looking at 89, is it a multiple of 3? Let's use that test of divisibility. 8 add 9 is 17, and 17 is not a multiple of 3 because 15 is. I don't need to check whether it's a multiple of 4 or 6. It's not a multiple of 5 because it doesn't end in 0 or 5. Let's check whether it's a multiple of 7. Thinking about my 7 times tables, I know that 84 is 7 times 12. So the next multiple of 7 after 84 would be 7 more 91. Nope, so that one is definitely a prime number. And I know at school we've been trying to learn our prime numbers up to 30 and some of us up to 50 as well. So you may well have recognised 37 there. Last question for today. Milan says 0.25 is smaller than 2/5. Explain why he is correct. Right, I've been doing an awful lot this week of changing fractions into tenths to make them into decimals. So that's how I'm going to explain it first of all. I'm going to look at 2/5 on my bar model. I can see 2/5 coloured in at the top. So if I look at the bottom, that will be 4/10. So 2/5 is 4/10, but that's not an explanation in itself. So let's carry that on. 2/5 equals 4/10, and that is 0.4. and 0.25 is smaller than 0.4 because I've got 4/10 in 0.4 and only 2/10 in 0.25. The other way of doing that would be to compare them both as fractions. So I'll move that answer out of the way and think about them as fractions. So one already is a fraction. I know that 0.25 is a quarter. So 0.25 is a quarter. Now I can compare a quarter and 2/5 by looking at them over a common denominator. So the lowest common denominator for those numbers is 20ths. So let's turn them both into 20ths. So remember, to make an equivalent fraction, you do exactly the same to the numerator and to the denominator. So to change a quarter into 5/20ths, I multiplied both the numerator and denominator by 5. And then to change 2/5 into 8/20ths, I multiplied both the numerator and the denominator by 4 in that case. Now that still isn't my answer, I still need to explain it. So my explanation is, after I've done that working out, so 2/5 is larger than 0.25 because it is 8/20ths and 0.25 is 5/20ths. So that's the end of this week's rapid reasoning. Next week, I'm arranging for some guests to be able to help with me. I've got some Year 6 children that are going to do some of their maths early, and then they're going to do the explaining as well. But for today, because it is VE Day, whether you're watching this before or afterwards, I hope you enjoy your celebrations. Be kind to everybody and stay safe. And I'll see you next Monday with all of my guests coming towards the end of the week. So for now, I'm just going to carry on with my cake and plan my picnic with my family later. Bye-bye, everybody.